Hi guys, welcome back to the new video. Today's topic trigonometry, and this is the second lecture of trigonometry. In the previous lecture of trigonometry I have said about all the synopsis and all the basics of trigonometry, like solving different kinds of problems regarding thetas and how to know the hypotenuse, adjacent, etc. And I have also told about the trigonometric table, which consists of all the values of sin theta, cos theta, tan theta, and etc. of all the angles like 0, 30, 45, 60. Everything I have covered in this lecture, and this lecture contains now a small diagram and very important identities of trigonometry, which are basically useful for solving each and every problem. Each and every problem must contain those identities. Okay, shall we start? Come on. Now today's topic, trigonometry. I told you guys that I'll show you a small diagram. This is the diagram. Now I am considering this angle as 0 degrees, this as 90 degrees, this point as 180 degrees, this point as 270 degrees, and this point again as 360 degrees. Are you guys getting? I am starting from this point. This is 90 degrees. Again from here, this is 180 degrees. First, we'll consider pointer in the middle, and when I am covering a quarter angle, that means it is 90 degrees. When I am covering a half semicircle like this, that means it is covering an angle of 180 degrees. From here, when I am covering this angle from 0 to 270, that means it is covering an angle of 270 degrees. When I am starting at point 0 degrees and rotating to 90, 180, 270 and again back to 0, that means 90, 90, 90, 90. 4 90s, 4 into 9, 36, that means 360. This is the quarter angle, this is the semicircle, this is a semicircle including a quarter, that means 180 degrees plus 90, that is equal to 270 degrees. And again a quarter angle, that means total 360 degrees. This is 180 degrees, this is 180 degrees, total it is 360 degrees, and this is a quarter angle. Are you guys getting? Okay. Now we'll go into this table, this diagram. The angles from 0 to 90 degrees, just a minute, 0 to 90 degrees. From 0 to 90 degrees here, all the values are positive. That means here sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta. Here everything is positive. Sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta. Where it is here all are positive. I am writing all are positive. Okay, all the values are positive. That means sin theta, cos theta, tan theta, all. We'll consider all the angles. All the angles are positive from 0 degrees to 90 degrees. All the angles are positive. Sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta. Now while coming to 90 to 180, here in 90 to 180 only sin theta and cosecant theta are positive. Only these two values are positive in between 90 degrees to 180 degrees. That means sin theta and cosecant theta are positive. Sin theta and cosecant theta are positive. Cos theta, tan theta, secant theta, cot theta are negative from 90 degrees to 180 degree in the second quadrant. Consider this as first quadrant, this as the second quadrant, this as the third quadrant, this as the fourth quadrant. Okay, first quadrant, second quadrant, third quadrant and fourth quadrant. 0 to 90, 90 to 180, 180 to 270, 270 to 360. In the first quadrant, all are positive. In the second quadrant, only sine theta and cosecant theta are positive. Okay guys, in the first two quadrants, for the first quadrants, all are positive. In the second quadrant, only these two are positive. Just a minute guys, let me check the video is recording in the way or not. Just a minute. Yeah, it's good. Okay, now in the third quadrant, tan theta and cot theta are positive. In the third quadrant, tan theta and cot theta are positive. And I will tell you at the last a small trick also how to remember this. Don't worry. First, let me say all this. Now, in the third quadrant, tan theta and cot theta are positive. While coming to the fourth quadrant, secant theta and cos theta are positive. In the first quadrant, all the angles are positive. That means sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta are positive. While coming to the second quadrant, sin theta and cosecant theta are positive. And while coming to the third quadrant, tan theta and cot theta are positive. And while coming to the fourth quadrant, secant theta and cos theta are positive. Here all, here sin theta, here tan theta, here cos theta and secant theta, and here cot theta again. Now, I will tell you a small trick. 0 to 90, all the angles are positive. That means sin, cos, tan, secant, cosecant, cot, everything is positive. While coming to the second one, remember that sin theta and inverse of sin theta is positive. Okay, that means in the previous lecture I have told that inverse of sin theta, I am writing it here. Inverse of sin theta is equals to cosecant theta. This is the inverse. Inverse of cos theta is equals to secant theta. Inverse of cot theta is equals to tan theta. Now here sin, I have said that in the second quadrant sin theta and its inverse are positive. That means sin theta, inverse of sin theta, cosecant theta, sin theta and cosecant theta are positive. While coming to the third quadrant, tan theta, cot theta and its inverse are positive. Cot theta and its inverse are positive, tan theta. Cot theta is equals to 1 by tan theta, like means sin theta is equal to 1 by cosecant theta, cos theta is equal to 1 by secant theta, and cot theta is equals to 1 by tan theta. Here tan theta and cot theta are positive, sin and cosecant, because sin is inverse of cosecant, here tan is inverse of cot theta. Tan and cot theta are positive. First remember this, only this. Here sin theta is positive, tan theta cos theta. Okay, and in the second quadrant, in the first quadrant all are positive. In the second quadrant, sin theta means sin theta and its inverse, sin theta and cosecant theta both are positive. In the third quadrant, tan theta and its inverse cot theta are positive. In the fourth quadrant, cos theta and its inverse secant theta are also positive. Did you guys get it? Now I'll tell you a small trick to remember this. First, you know that in the second quadrant sin theta and cosecant theta are positive. In the third quadrant tan theta and cot theta. Fourth quadrant, first you have to remember all sin theta, tan theta and cos theta. Okay, now I'll tell you a small trick. All, consider this as silver, this S as silver. Okay, and this tan theta T as T. The tea we drink, tea. And the fourth as cos. That means we get C as cups. That means here all, I'll write it, all silver teacups. A all, S in silver, T in tea, C in cups. Okay guys, all, silver, T, cups. All means all the angles, silver means S, that means sin theta and its inverse. Here in each quadrant the angle and its inverse angle both are positive. Okay guys, S means silver, all silver, T means tan and its inverse angle is cot. This is C means cos and its inverse angle are secant, cos and secant are positive. Again I'll explain with a brief note. 0 to 90, quarter, 90 to 180, semicircle, 180 to 270, semicircle plus quarter, and 0 to 360, a complete circle. 0 to 90, all are positive. 90 to 180, remember this, all silver teacups. Don't see this, remember this, all silver teacups. S means sin theta. Sin theta and its inverse are also in each quadrant. Sin theta and its inverse are also positive. Okay, sin theta and its inverse means cosecant theta. Now moving to the third, first quadrant, second quadrant, third quadrant, fourth quadrant. You can also mark in this way. All silver. T means tan and its inverse, tan and cot. C means cos and secant, its inverse. This is very important. In some of the questions you will get that sin 90 plus theta. 90 plus theta means this is sin 90 plus theta. 90 plus, 90 minus means from 90 we have to move in the backward direction. 90 plus means we have to move in the forward direction. Sin 90 plus theta, sin 90 plus theta. 90 plus theta means it includes first quadrant. 90 plus theta, plus means we move in the forward direction, and minus means we move in the backward direction. That concept I'll explain while doing the sums, then you will get more clarity. Okay, remember that, remember this small point. Plus means forward, minus means backward from the angle. From the point, we'll say, from the point of the angle. From the point, that means this is the point from 90. 90 minus means backward, 90 minus means forward, 180 minus means backward, 180 plus means first. 90 minus means first quadrant, 90 plus means second quadrant. Again 180 minus means second quadrant, 180 plus means third quadrant. 270 minus means third quadrant, 270 plus means fourth quadrant. 360 minus means fourth quadrant, and 360 plus means again first quadrant. Guys, note it down, this is really very important. After this we'll move to the identities. I'll leave the board for 2 to 3 minutes. First copy and try to learn in this time. Guys, copy it fast and try to learn in this time. This diagram is really very important about the quadrant and angles. It will be used more in the while solving the problems. There are some of important identities that I will say now. Okay. Okay guys, I'm starting it. Okay, yeah. there are three very important identities. I'll write it here. Trigonometric identities. The first one is sin square theta plus cos square theta is equals to 1. The first one is sin square theta plus cos square theta is equals to 1. The next one is secant square theta minus tan square theta is equals to 1. And the next one is cosecant square theta minus cot square theta is equals to 1. Okay, I'll write the identity here again. This is the same. Sin square theta plus cos square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta is minus cot square theta is equals to 1. This is the same I have repeated here for better clarity. Sin square theta plus cos square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. These are three very important identities, guys. Each and every problem we use this kind of identities. This identity can be used in any way. If they ask for cos square theta, we use 1 minus sin square theta is equal to cos square theta. If they ask for cos square theta, we use 1 minus sin square theta. In the same way, these will be also used. And this is it. These are the three very important identities. Note it down. Sin square theta plus cos square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. Very important identities. These identities will be used a lot more while solving problems. Okay, and this is basically used in the situation where when the question is like cos square theta is equal to 1 minus sin square theta. 1 minus cos square theta, I'll write it roughly here. Cos square theta plus some x is there. Okay, we'll see cos square theta, just a minute. Cos square theta plus it is given 1 minus sin square theta. Okay, cos square theta plus 1 minus sin square theta, it is given in this way. So now we have to solve the problem. So now I'll do it in a way now. I know the identity as sin square theta plus cos square theta is equals to 1. That means cos square theta is equals to 1 minus sin square theta. That means this can be replaced by cos square theta. Cos square theta plus cos square theta is equals to 2 cos square theta. Okay. In this way, I will show one more example. First copy this. I'll show the examples, don't worry. First copy this. I'll show one or two examples regarding this and you'll get a better understanding when I show examples. Guys, completed? Okay guys, now I'll explain with an example, then you can get a better clarity. First I'll write the three identities here. sine square theta plus cos square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. This thing, sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. Now I'll show one example. Just a minute. Let me think. Secant square theta plus 1 plus tan square theta is equals to 2 secant square theta. Prove that LHS is equals to RHS. This is the thing we have to be proved. Okay. Now if you don't know, first think you don't know this identity. How will you solve? We'll go with some different methods which makes the problem really complex and finally will not get the answer. That I can say very confidently, finally we will not get the answer. But when I know the identity, first I will revise my identities: sin square theta, secant square theta and cosecant square theta. Here sin square theta minus tan square theta is equals to 1. First I will write that secant square theta minus tan square theta is equals to 1. First I have written my identity. Now here there is 1 plus sin square theta and secant square theta. So when I shift this sin square theta here, that means tan square theta, 1 plus tan square theta. That means it is left with secant square theta. Secant square theta, 1 plus tan square theta means secant square theta. That means 2 secant square theta. Secant square theta plus secant square theta is equals to 2 secant square theta. LHS is equals to RHS. Done. So these identities are used in this way. So when I do with some small examples, you can know the value of these identities. That's why I have done with this example. Now we'll continue with the identities. Okay. Identities now again. The first identity is sin 90 minus theta is equals to cos theta. Cos 90 minus theta is equals to sin theta. Just a minute guys, let me check the video is visible or not. Yeah, it's visible. This is the second identity, and the third one is tan 90 minus theta cot theta. Fourth one is cot 90 minus theta is equals to tan theta. These are the four entities, and the fifth one is cosecant 90 minus theta is equals to secant theta, and secant 90 minus theta is equals to cosecant theta. Okay guys, these are the 6 important identities, and now I'll explain how we'll get this also. Okay, now first we'll go to this diagram 0, 90, 180, 270 and 360. Sin 90 minus theta cos theta, odd multiples of pi by 2. Okay, first I'll write all the identities, then I'll start explaining the concept. First I'll write the identities. Okay guys, so this is a bigger concept. I have to explain it more clearly, then you will get more clarity regarding that concept. First I'll write the identities. First you learn those identities, then I'll give the proofs and explanation regarding these identities. Okay, and the seventh one is sin A plus B, sin A cos B plus cos A sin B. This is the seventh identity. And now sin A minus B, sin A cos B minus cos A sin B. And the ninth one is cos A plus B, cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. When you move for the 10th identity, cos A minus B, cos A cos B plus sin A sin B. This is the 10th identity. And okay, these are completely formulas. Sin A plus B, sin A minus B, cos A plus B, cos A minus B are completely formulas. Okay, you have to learn these formulas, and these proofs are not more important while doing competitive exams. While going for competitive exams, these proofs are not more important. And the 11th identity is sin 2A is equals to 2 sin A cos A. Sin 2A is equals to 2 sin A and cos A. Sin 2A is equals to 2 sin A and cos A. And sin 2A can also be written as 2 tan A by 1 plus tan square A. Sin 2A is equal to 2 sin A cos A, or sin 2A is equal to 2 tan A by 1 plus tan square A. It can be also written in this form. The writing part, while we you guys must consider or doubt that, so from which formula we should choose, this one or this one. The formula choosing will be depending upon the while solving the problems. The situation demands whether to use this problem or this formula to find the solution. Okay, now moving to the 12th one, cos 2A, 2 cos square A minus 1, or 1 minus 2 sin square A. Here, when we want to write in the terms of cos, we use this formula, 2 cos square A minus 1 or 1 minus 2 sin square A. When we write in the terms of cos, we use this one, and when we want to write in the terms of sin, we use this one. Now 13th formula. 13th formula is tan 2A. Tan 2A is 2 tan A by 1 minus tan square A. Tan 2A is equals to 2 tan A by 1 minus tan square A. Don't confuse, guys, don't confuse in between this formula and this formula. When we are considering about sign, we use the sign plus. Please note that point. We use the sign plus. When we are going for tan 2A, we use the sign minus. This is minus, okay? This is not equal to, this is minus. We have to use the sign minus here. We have to use the sign plus here while considering sin 2A and tan 2A. This is the 13th formula. And 14th one, tan of A plus B. Tan A plus B is equals to, I am writing it down, tan A plus tan B by 1 minus tan A into tan B. Did you guys get it? Tan A plus tan B by 1 minus tan A into tan B. While moving to the 15th formula, tan A minus B. Tan A minus B means tan A minus tan B by 1 plus tan A into tan B. Okay, these are some very important formulas and identities. Guys, don't worry about these identities. I'll explain it very clearly while using this type of diagram which I have drawn in the previous page. I'll explain it to you. Don't worry regarding this. First, write this everything. Don't worry, I'll explain it in the next lecture where you can get very confident and you will get a complete grip on this these 6 identities, secant 90 minus theta, these type of identities. Guys, don't worry, I'll explain it very clearly. And there is a small topic to explain this. There is a new topic which I have to be said, like odd multiples of pi by 2, odd multiples of pi by 2, and where to use the sign, this time where to use the sign positive and negative, when will the sign be used as considered as positive and when will be considered as negative. It is a lengthy topic, but I'll explain it very clearly. No worries about this. Just first learn this 15. No worries about this 1 to 6. Okay, don't worry about this 6. I'll completely explain regarding, I'll completely give a grip on the topic. Okay guys, don't worry. There are some multiple topics, this so these proofs are not included, but I'll completely say why you are getting this cot theta when you using this cot 90 minus theta, when you are getting tan theta. I'll completely say that, don't worry about it. That completely includes the dot multiples of pi by 2, and it includes that pi by 2, and depending upon the table also we should change the values here, cot theta and tan theta, and depending upon the angle, and sometimes minus and sometimes plus. See, when we are moving sine, see this sine 90 minus theta. 90 minus means first quadrant. Sine in first quadrant, odd or positive, all are positive. Odd multiples of pi by 2. Odd multiples of pi by 2 means cos changes to sine, changes to cos. Odd 90 is an odd multiple. Pi by 2 means is nothing but 90. Pi by 2, 180 by 2 means nothing but 90. Odd multiples of pi by 2 means sine changes to cos, tan changes to cot, cot changes to tan, secant changes to cosecant, and cosecant changes to secant. Pi by 2, 90. 90, and sine 90 minus theta means this one. 90 minus theta means first quadrant. In first quadrant all are positive, no negatives. That means pi by 2, it is here it is 90, that means odd multiple of pi by 2, so it becomes cos theta. So these topics will be included, that is the reason why I am not saying it. Cos 90 minus theta means cos 90 minus theta. In the second quadrant, all in the first quadrant all are positive. Again 90, it is a odd multiple of pi by 2, and cos changes to sine, cosecant. In that way it includes. So I have to complete this topic. I'll complete this topic in the next lecture. You'll get a complete grip on this particular topic. This is really important. That's why I'm just not telling it briefly. It have to be said in a very clear cut way. So in the next lecture I'll explain regarding this synopsis, and there are small topics which have to be said. I'll complete that also. First you guys copy these formulas. Okay guys, if you want, take a screenshot of this fast. If you want, take a screenshot of this. Don't worry about this. I'll give a complete crystal clear explanation about this. Just you will get full confidence on these 6 identities. I'll guarantee you that. Okay guys, this is just a brief explanation. Don't worry, I'll give a complete clear cut explanation. No worries about the 6 identities, but these are the formulas. You must learn these identities and formulas. There is no use of proofs, but you have to learn these formulas. These 15 formulas should be learned. I'll give a clear cut explanation regarding this 6, then you start learning. It will be more easier. Okay guys, that's all for this video. If you like the video, hit the like button and subscribe to the channel, and stay tuned for the next videos. And the next lecture will be also on the synopsis of trigonometry. After that, after completing the complete synopsis perfectly, then we'll go for the sums. Okay guys, stay tuned for the videos. Bye bye.